Elisha Gray was one of our more important and prolific inventors, yet today he's almost unknown. He was born in 1835 in Ohio and was raised on a farm where he was expected to be able to solve all types of mechanical problems with minimal resources. He went on to attend Oberlin College for several years, though he never received a diploma. While at Oberlin, he taught classes in electrical theory and built specialized equipment for their science labs. In 1865, he had his first invention, a self-adjusting relay for the telegraphic system. You will recall that a relay is a form of electrically controlled switch. Relays are useful in many applications, and Gray's invention was specifically to help address the problems of coping with the electrical differences between disparate cross-country telegraph lines. He received his first patent on this device 2 years later. In all, he would be granted more than 70 in his long career. In 1869, Elisha partnered with Enos Barton to found Gray and Barton Company in Cleveland, Ohio. This company manufactured telegraph equipment for Western Union Telegraph Company, the largest telegraph company in the world. Eventually, this company split into two parts, with the parts distribution business moving into the new company called Gray Bar Electric Company. Today, Gray Bar employs more than 8,000 people and has annual sales of over $6 billion. Very few businesses survive for a century and a half, much less prosper. In 1872, Western Union, using money from the Vanderbilts and J.P. Morgan, bought into Gray and Barton Company and renamed the remaining company Western Electric Manufacturing Company of Chicago. This company manufactured typewriters, lights, and a wide variety of other equipment. It was also a major supplier to Western Union during a period of huge growth. Western Union would be absorbed in 1915 by AT&T, the American Telephone and Telegraph, the monopoly telephone vendor in the United States. The business continues today, though the names have been changed along with multiple mergers and reorganizations. One important byproduct of the Western Electric AT&T operation was the founding of Bell Telephone Laboratories in 1925 as a 50-50 partnership. This legendary laboratory, where our mentor Bill Cheswick, by the way, once worked, produced many inventions, including the laser, the transistor, completely transformed computer science through the development of the Unix operating system and the C and C++ programming languages. They also pioneered radio astronomy and satellite communications. In all, Bell Laboratories researchers have been awarded 8 Nobel Prizes. Anyway, going back to Elisha Gray, it's clear that he could invent and develop useful technologies and build companies which could stand the test of time. But his greatest contribution was yet to be seen. In 1874, he retired from these companies and continued his research. His current project was to create a practical way to send several telegraph messages over a single wire at the same time. You see, in 1874, the country was growing very quickly. The Transcontinental Railroad had connected east and west and had been operating for only 5 years. Already, the need for communications around the company was straining Western Union's ability to string new wires and to keep the wires that they had going. Additional capacity between two cities meant adding additional wires, which was expensive and slow. William Morton, the president of Western Union, contracted with Elisha Gray and with Thomas Edison, another one of our great inventors, to develop a way to send multiple messages per wire. Both of them, by the way, had extensive backgrounds in telegraphic development. In other words, what Orton wanted was a way to add a device at each end of a telegraph wire, which would have the same effect as having a dozen or more new wires between those 2 points. Gray reasoned that one way to send multiple messages concurrently would be to encode each message using a different tone or vibration, much as you can tell the difference between 2 different notes played on the piano. Mathematically, this is much the same way that AM radio operates even today. Gray's idea required that the sending telegraph key not send a pure direct current voltage, but a modulated tone which corresponded to the channel over the wire. In other words, you might have a low signal for one key and a high signal for another key. The device on the receiving end would have to be able to tell the difference between the two tones so that you would only receive the dots and dashes that corresponded to your channel. By 1874, Elisha had demonstrated this invention several times. Matter of fact, just after Christmas and just before New Year's 1875, he demonstrated his transmitter connected to a piano keyboard, and using his new invention called the loudspeaker, he used it to play music. This was the direct ancestor of today's electronic music and musical synthesizers. In 1875, he was issued a patent for this tonal telegraphic system. But Gray had done more than just improve the telegraph. He had found a way to transmit sounds over a wire and then convert them back to sound on the other end. He was very close to having what we would call a telephone. The one thing he did not have was a microphone, a way to convert sound into electrical signals. He continued to work on this, and finally, on St. Valentine's Day, 1876, he filed a patent caveat. Now, a patent caveat is what we would call today a provisional patent application, or it is an application to the patent office that will be filled out and strengthened with additional filings. His patent caveat described a functional telephone that had a working microphone based upon a liquid process. In his design, a conductive diaphragm was placed into a conductive liquid such that electricity could pass from the diaphragm to the liquid. If the diaphragm barely touched the liquid, the circuit would have a high resistance and therefore would only allow a small amount of electricity to flow. However, if the diaphragm was more nearly immersed in the liquid, the resistance would be reduced, allowing more electricity through the circuit. The key point was that sound, such as my spoken voice, could vibrate the diaphragm, producing varying electrical current corresponding to the vibrations of the sound. In other words, Gray had a workable microphone, which gave him a workable telephone system. Now, on that exact same day, Alexander Graham Bell's attorneys filed a patent for his version of the telephone. The designs had amazing similarities. Now, to this day, we cannot be sure of what happened next. After extensive courtroom battles stretching over years, Bell was awarded the patent for the telephone. There have been accusations that the patent examiner was bribed to allow Bell's side access to Gray's filing. In fact, the patent examiner admitted to taking a $100 bribe later for that point. It is clear that whatever happened, Bell's side bent the rules severely if they were not broken. Bell likely perjured himself in testifying how some last-minute modifications were made to his patent filing, after Gray's side claimed Bell had reviewed Gray's filings. It's also important to note that over the years afterwards, Graham Bell developed a reputation for trying to steal inventions from other inventors, including the Wright brothers. But the courts ruled that Bell was the inventor of the telephone. Interestingly enough, Gray went on to create the Telautograph. This device allowed writing over long distances. Someone could write with a pencil in one city, and a mechanical pencil in another city would mimic the writer's motion, making it possible to send a written message from place to place. And this message could be text, or it could be a picture. It could be a signature, because this was not sending characters, but actually recreating the physical motion of the pen. This was most valuable as a way to sign legal documents remotely. And after all, in this era, travel could take long amounts of time. It was quite expensive. So signing a document remotely could be very advantageous. The Telautograph is the precursor to the modern fax machine, but it's also much more. It is a pioneering use of servo controls. Servos are devices that react in proportion to their inputs. Today you see servo controls in many places. Most RC cars are steered by servo mechanisms. You see, servos operate by comparing the input signal with their current state and calculating a difference. If the servo is told, move the car to the left, and it senses that the wheels are pointed straight forward, the difference will cause it to alter the output of the servo to turn the wheels to the left. But if the servo already notices that the wheels are pointed to the left, then it will not change the output. This is the basis of feedback, which is important for any adaptive system, and has become very, very important in modern systems. Elisha Gray was decades ahead of his time. Gray also pioneered television by adapting and developing a device he called the telephone. It used the fact that selenium, a relatively newly found element, could be sensitive to light and change its electrical characteristics depending upon how much light is shown upon a bit of selenium. This allowed him to create a crude camera with an array of bits of selenium that each could have a larger or smaller amount of light on it, corresponding to what you would think of as the pixels on a black and white picture. The display was made by opening or closing an array of small shutters over a light or dark background. This was not particularly satisfactory, but it did work. A similar selenium grid is the basis for modern Xerox copiers and many scanners, and was the basis for black and white television cameras up until the 1970s. He was, again, many decades ahead of his time. Gray continued his research projects up until his death in 1901 at the age of 65. Today, Gray is usually discussed in the context of his fight with Bell. Gray spent half a century studying and developing new electrical equipment and working with the finest electrical minds in his time and some of the greatest inventors of his time, including Thomas Edison. Bell was a relative newcomer to electricity, having spent his time working with deaf students. When he consulted Joseph Henry at the Smithsonian for help in 1875, he confessed that he did not have the necessary knowledge to create a telephone. In fact, Bell's telephone first worked in March of 1876, months after Gray's design. However, Gray's other contributions have also had a huge impact on our modern world. He continued his drive to improve the world up until his death. At the time of his passing, he was working on a way to communicate with ships by sending messages through the water. We should be pleased and proud that Gray was able to help our lives in so many ways, and it is truly sad that more people do not know of his accomplishments.